Tuesday, November 18th, 2025. AGNDD intelliReport topic: Bizarre quantum behaviors in shocking substance. Please pardon any visual and informational inaccuracies in this entirely AI-generated article-based video. Scientists witnessed bizarre quantum behaviors in a shocking substance. Quantum oscillations are typically found in metals, but finding this same electron wiggle within the bulk of insulators is a big surprise. By Darren Orff. Published November 18, 2025, 2 p.m. EST, Popular Mechanics. Here's what you'll learn when you hear this story. For more than 7 years, scientists at the University of Michigan have explored the strange quantum oscillations of the Kondo insulator ytterbium boride, YBB12. In 2018, the team discovered that quantum oscillations arose from the bulk of the insulator under intense magnetic fields, which is counter to the behavior of a type of well-known material known as a topological insulator. A new study, leveraging powerful magnets at the National Magnetic Field Laboratory, confirms that these oscillations are intrinsic and occur in the insulating bulk of the material, leading to questions about what practical purpose this bizarre quantum behavior could serve. Some of history's biggest discoveries initially appear to serve no practical purpose. When scientists devised the first working lasers a few decades after Albert Einstein's theory of stimulated emission in 1917, few understood what practical applications they might have. Now, of course, most of the technological world relies on them. And it doesn't stop at lasers. Lou Lee from the University of Michigan has spent years exploring a strange quantum behavior in the insulator known as ytterbium boride, YBB12, which is also known as a Kondo insulator. In 2018, Lee and his team published a paper in Science detailing a strange phenomenon regarding YBB12. While its surface acts as a conductor, its bulk, or interior, acts as an insulator. But the team found evidence of quantum oscillations in the material's bulk, aligning with previous research conducted by scientists at the University of Cambridge years earlier. This result confirms that Kondo insulators have a dual nature. They are both electrical insulators and itinerant metals, Lee told Physics World at the time. This duality is a surprising consequence of the strong correlations between the electrons in the material. Fast forward 7 years later, and Lee and his team have gathered even more evidence of this striking quantum behavior in a study published in the journal Physical Review Letters. Working at the most powerful magnet lab in the world, the National Magnetic Field Laboratory in Tallahassee, Florida, Lee aimed to confirm that these oscillations did indeed form within the bulk of the insulator and that they were intrinsic to the material. The community has not yet reached a consensus on fundamental questions about the quantum oscillations. Debates persist about whether the oscillations originate from the surface or the bulk, and whether they are intrinsic or extrinsic, the authors wrote. It is essential to obtain direct thermodynamic evidence to determine whether the thermal properties originate from the same quasi-particle band as the quantum oscillations. While this study confirms the intrinsic bulk origins of these quantum oscillations, the authors note that this behavior only arises in magnetic fields at the threshold of 35 Tesla. For comparison, an MRI machine only leverages a magnetic field of 1 Tesla. Admittedly, Lee said he isn't quite sure where this new discovery leads the field. Topological insulators, materials that are conductive on their surface but insulators in their bulk, have enabled new quantum technologies, but a material where quantum oscillations occur in the bulk is still a bit of a question mark. I wish I knew what to do with that, but at this stage we have no idea, Lee said in a press statement. What we have right now is experimental evidence of a remarkable phenomenon. We've recorded it and hopefully at some point we'll realize how to use it. If the discovery and creation of the laser provides any historical context, that realization could have profound consequences for future technology. Darren Orff, contributing editor. Darren lives in Portland, has a cat, and writes edits about sci-fi and how our world works. You can find his previous stuff at Gizmodo and Paste if you look hard enough.
Thank you for watching this AGNDD intelliReport, dear viewers. Please like, subscribe, and click the bell button to get notified during new uploads. And make sure to tune in next time. Stay safe and healthy. Cheers.